All right, welcome to 9A Classifying Polygons. This is my recording voice. What is a polygon? A polygon is a closed plane figure with straight sides. Closed means it's not left gaping open like that. It goes all the way around, it connects. And plane means it's flat. So you could lay it flat on a piece of paper and draw it. It's not three-dimensional, it's flat ski. And what about the sides? They are straight. There is no curves involved in a polygon. That's interesting, isn't it? Yes. And each straight side is called an edge, and we need to know that word edge. This is an edge. Maybe I'll make it red. That's an edge. So on the sides, each of those sides, we're not going to call them sides anymore. We're going to call them edges. And where two edges meet is called a vertex. A vertex is which two of these sides get together and they form a vertex. So this here is a vertex. How many vertices are there in this? Vertices is the plural of vertex. In this convex polygon, there's 1, 2, 3, 4, 5. And the vertex is actually that point. So these are the points here. And what I've just outlined is the angles that we're going to eventually measure within this polygon. Now, are we okay with polygons so far? They're flat, they got straight sides, and they're closed. So they meet up. Then there's two types. So we got these closed figures. So you can see the difference. The difference between a convex and a non-convex polygon is that one is all outies. Right? None of them are going to curve inward and be bigger than 180 degrees. In a non-convex or concave polygon, they have at least one vertex pointing inward. And so this angle, this inside angle, is going to be bigger than 180 degrees. 180 degrees is a straight line. So as soon as we bend further past 180 degrees, we've got pointing inward. And so that's a non-convex polygon. Most of the time we deal with convex polygons because they just seem to be what comes up in our lives. But as soon as you get one of those angles pointing inward and sort of making an indent into the shape, you've got non-convex. Or concave, but most of the time I hear non-convex. I'm going to keep flying through this so I can make a nice succinct video, but I will stop for questions whenever I need to. So polygons are classified by the number of sides they have. So that's cool. So all we need to know, I'll come back to regular polygons, is that if a polygon has 3 sides, everybody, what's it called? Triangle. Or, if you want to be super fancy pants, at your next Scrabble game, you could call it a trigon. That sounds fantastic. That sounds like a sci-fi planet on the planet Trigon that has 3 sides. If you have 4 sides, you get a quad, quadrilateral, or tetra. Tetra means 4 as well. So these are ancient, probably Latin, maybe Greek, words that mean those numbers. So tri means 3, quad or tetra means 4. What means 5? Penta. So if you have penta, you have 5. You will need to know these. You will be tested on these. You'll need to know these words. Math class, we have to learn words. If you get to 6 sides, you've got a hexagon. Hex means 6. And very similarly, hepta or septa. You've heard of September? Really, September should be the 7th month. October really should be the 8th month, but we got fouled up somewhere. Septa means 7, octa means 8, and then we get into the less familiar ones. A nonagon has how many sides? Yeah, so you're going to have to remember that. What is the name for a 9-sided figure? I might have to quiz you on this. 9 sides is nonagon. At least they all end with gon at a certain point. There's always a gon version of everything. If you remember the gon versions, you're good. A hexagon has 6. A pentagon has 5. A decagon, like a decade, has 10. A 10-sided figure. So it's got 10 straight lines and they connect. Doesn't necessarily mean that it's convex or non-convex. It can still be a decagon if it follows those rules. Question? I'm getting there. So what we do, see how the deca carries on? This is a decagon. We have an undecagon, like one, un. You ever play Uno? Yeah, so that means last 1 card. So it's deca plus 1, undecagon. Dos means 2. So that's, yeah, but this is as far as we need to know, is up to 12. So a dodecagon has 12 sides, 10 plus the 2, dodecagon. 11 is 10 plus the 1. Okay, and all these names, I think you guys are going to be pretty good with this. Don't ask me hard questions. So, regular pentagons is the hardest one. I have seen people get this wrong so many times, and you just don't have to. What is a regular polygon? A regular polygon is simply all sides equal. If all sides are the same length, you get a regular polygon. If I want a regular pentagon, look at what that looks like. Each of these is the same size, and we can tell that by these little lines. These little lines are telling us, without measuring it, that those are all the same length. And you know what else happens when you do that? You get all these angles at the vertices. They're the same. So whatever that measures in a regular, not irregular, in a regular polygon, this isn't a pentagon, they will all be equal to each other. All of these angles are equal. Why is this one an irregular pentagon? Go. Yep, at least one side is not equal to the others. Even if these two happen to be equal to each other, the others are all over the place. So that's irregular. What's an example of a regular triangle? That has a special name. What is it? A regular, I'm going to try my best to draw one without actually doing it. What is a regular triangle? They've all got, we're going to say they all have the same length. What's the name of that kind of triangle? That, how about the word, every triangle is three-sided? But you're thinking, equilateral. Anyone? Anyone? That also means that each of these angles are equal as well, which is so exciting. So we've seen regular polygons before. So if I were going to draw an example of a non-convex octagon, how many sides would it have? 8 sides. And what would make it non-convex? Let's go back up to the definition. Non-convex have at least one vertex pointing inward, which makes one interior angle, this one, bigger. I'll leave you to draw one, and I'll move on. There's only a couple other things we need to do, and that's name them. Polygons are usually named Fred, Ralph. I've seen a polygon named Ralph. That's not true. Polygons are named, this is the truth here, with the capital letters for each vertex. Vertex is where these edges meet. So we'll call this vertex A, this one B. They don't have to be in alphabetical order. And then you name them in succession. What does succession mean? One after the other. So I can call this one A, B, C, D, A, B, C, D, or I can go anti-clockwise. I could call it quadrilateral, A, D, C, B. It doesn't matter, but it makes a lot more sense to go alphabetical when given the chance. And the last word I need to tell you is a diagonal. A diagonal is a segment, which is a line that finishes at both sides and joins two vertices, dividing a shape into two parts. So this diagonal, we'll ignore the other diagonal, leaves us with a triangle on either side. That's a diagonal. This one, going from vertex to vertex, would also leave us with a triangle on one side and a triangle on the other side. Example 2, state the type of this shape and whether it is convex or non-convex. What do you think? Is this shape convex or non-convex? We have one vote for convex. Any votes for non-convex? I don't see any angles that are pointing inward and that would make 180 degrees. So this one is convex. Let me just check my definition of convex back here, because I can always check the book. Convex polygons have all vertices pointing outward, and all the inside angles are smaller than 180. So this one is definitely convex. And is the shape regular or irregular? Immediately you know that because the sides are different lengths. Okay, that was a long video, but there it is. Now I'll take questions.